We decided to incorporate movies into machine learning for our final course project. The goal was to recognize the genre of a movie based off words in the movie script. We immediately recognized that this is a classification task, but for it to work, we need a large amount of data. For data collection, we took advantage of IMSDB's collection of movies and corresponding scripts. As you can see, this website has the movies, the genres, as well as the scripts. We built a scraper using Python and corresponding packages like Beautiful Soup. So as you can see, importing Beautiful Soup, parsing the data, scraping the data. And as you can see, we then cleaned each script by converting the script to lowercase letters and removing stop words and punctuation. Our methodology was to focus on 3 specific genres: action, comedy, and horror. We chose only 3 because we had limited data. 2 classifiers that we found that were good at text classification were the naive Bayes and SVM classifiers. We compared 2 genres at a time using both naive Bayes and SVM. After running our Python scripts on each genre, which takes several minutes to run, we got these outputs. We categorized our classifications into 4 categories: without TF-IDF and without stemming, 2, without TF-IDF and with stemming, 3, with TF-IDF and without stemming, and 4, with TF-IDF and with stemming. So to elaborate on what stemming and TF-IDF are, we use stemming to tackle the issues of repeated words. While parsing through our dataset, we noticed that some of our bag of words at times contained transformations of words already in the bag. For example, the script for the movie 15 Minutes, our bag of words contained the words open, opens, and opened, which were essentially the same word. We used Lancaster stemming that reduced the words to its bare bones. To further improve our accuracy, we looked into TF-IDF transformations on our dataset. The TF-IDF algorithm weighs the frequency of a word in a document and how significant that term is within an entire collection of documents. This chart on the left represents the first category, without TF-IDF and without stemming. So we decided to try to categorize and classify movies based on their scripts between action and comedy. And we did this through naive Bayes the first time and then SVM the second time. And through the Python script calculations, we ended up with an accuracy of about 75% with naive Bayes, and then about 76% for SVM. And then on this side, we have the second category without TF-IDF, but this time we're adding stemming. And because of adding stemming, we got slightly higher results at 77% and about 78%. We did the same thing for action horror. And you can see here that we have neither TF-IDF nor stemming. And then on this side, we have stemming. And these results slightly differ as well. We have about 71% here, slight decrease over here, and a pretty significant increase in accuracy for the SVM model. And same thing again for comedy and horror. This time we have stemming, this time we don't. And I would say the results in accuracy are about the same, slightly decreased with stemming for both naive Bayes and SVM. And then categories 3 and 4 are with TF-IDF, without stemming, and then with both. So here we can see that when we try to classify movies between action and comedy with TF-IDF and without stemming, we got these results. And with both, we got slightly higher results over here and about the same results in accuracy over here. And again, same idea, we did the same thing for action horror. We have decrease if we added stemming, and then a slight decrease if we added stemming again. And then comedy and horror, increase in stemming, increase in percent accuracy with stemming, and about the same accuracy for both. In the end, after taking the averages, we found that without TF-IDF and with stemming provides the highest percent accuracy, and then without both, and then with just TF-IDF, and then TF-IDF and stemming. And a limitation was that while we tried to apply sophisticated techniques to improve the accuracy of our classifiers, we were severely limited by the data size of 700 samples. After a lot of optimization, we found that the stemming method alone, as you can see here, works best for our dataset. In the end, we were able to classify a movie based on its scripts with about 70% accuracy.